Good morning, students. Welcome to the online classes. Today, I am going to continue with chapter 4, elements of weather and climate. The second element that we are doing here was pressure belts. So, I have drawn a picture of the pressure belts here. There are actually 7 pressure belts, okay, on our earth. And if you see, okay, there are 7 pressure belts. 1, 2, 3, 4, 5, 6, 7. 7 pressure belts, okay. This is known as polar high. This is known as polar high pressure belts, okay. This is known as, the second one is known as subpolar low pressure belts or circumpolar low pressure belts, okay. This is also known as subpolar, okay, low pressure belts. Now I cannot fit the pressure belts here, so this is the area where you have the same kind of temperature, the same kind of humidity, the same kind of rainfall, as well as the same kind of pressure in this particular belt, okay. Therefore I have basically, okay, leveled the belt, okay, into 2 parallel lines. This is called a belt. Therefore this is known as polar high, this is known as subpolar low, and this is known as, okay, subtropical high pressure belts, okay. This is also known as high pressure belts. Now here is known as equatorial, okay, equatorial, okay, low pressure belts, okay. This is all, I am coming to that, okay. Then subtropical high pressure belts, and this is also known as subpolar low pressure belts, as well as this is known as polar high. Now if you look here, okay, if you look here on the blackboard, you find, okay, except the equator, all the others have matching pairs. If you look at equator, it is at 0 degree, okay, latitude, and if you look at subtropical high, it is at 30 degree latitude. Subtropical high, so they have matching pair. Subpolar low at 60 degree latitude, so they have a matching pair. On here also in 90 degree, you have polar high and polar high, that is a matching pair. So there are actually 7 pressure belts, okay. So before learning about these pressure belts, we have to understand the thumb rule. In the last video, I have already explained to you, okay, about this thumb rule, okay. So warm air rises, expands, okay. There is low pressure of air near the earth, which causes low pressure belts. So in the second, you find cold air sinks due to gravitational force of the earth. Okay, reason high pressure of air on the earth's surface causes high pressure belts. Wind always moves from a region of high pressure to low pressure. It is also called HP to LP, okay. So you have to understand this thumb rule in order to understand this, okay. So I have already told you that equator is a place where you have direct rays of the sun. So last time only we have studied about that, okay. So here we have to understand, okay, that, okay, this is the horizontal distribution of pressure. This is known as the horizontal distribution of pressure. I am rubbing the blackboard, okay. I am writing the name of this, okay, pressure belts, okay. This is known as horizontal, Horizontal, horizontal distribution of air pressure. Now whenever we are talking about the horizontal means this is the line. Vertical means this is the line. So I am drawing these lines right now. Now please concentrate here, okay. When I am talking about horizontal distribution of air pressure or components, we are moving from equator towards the poles. We are moving from equator now towards the poles. So from equator we are moving from towards the poles. So this is the place where you have equator. and this is the place where you have poles. So whenever we are talking about horizontal distribution of pressure, we have to understand how the temperature rises, okay? So temperature rises when we have sun, okay? And maximum sunlight is received at the equator. So maximum sunlight is received at the equator. So this place becomes, okay, what? A hot place, okay, where the land as well as the air around it gets warmed up. When the air gets warmed up, okay, now you have to look at the term rule, okay. When the air gets warmed up, okay, as well as the land, what happens? It expands and rises. It expands and rises. So when the air around this area gets heated up as well as the land gets heated up, the air rises up. The warm air is lighter, therefore it rises up. So it expands and rises. Now rises to a level where you have tropopause. So tropopause is the final layer of the troposphere. Tropopause. Now when they reach the initial boundaries of the tropopause, okay, here is the area where this warm air gets converted into cold air. Because, okay, what happens is number of gases are found in the troposphere which are known as cold gases, as well as the wind which is moving from the poles also basically react with the warm air and causes the warm air to change into a cold air. When the air becomes cold, it bifurcates into two different directions, north and south. This is the north side, this is the south side of the hemisphere. So when it bifurcates, what happens? It becomes cold. Now cold air, if you look at the thumb rule, sinks. It sinks, it expands. Due to what? Okay, because cold air is heavy. It is denser than the warm air. So when it becomes heavy, it sinks. It gradually, okay, descends towards the earth. This is known as subsidence. This is known as subsidence or descending order. Here you find ascending, the air is ascending. Here the air is descending. Okay, I am just dropping this arrow because it is in the wrong side. So when the air descends, it descends due to not only the air is heavy, but due to the gravitational pull of the earth or the gravitational force of the earth. Okay, so what happens? Here you have high pressure. So therefore you have high pressure zones. Here you have low pressure zones because the warm air expands. So when the warm air expands, what happens? There is less air. Here, there is less air here. The amount of air is less, but the amount of air is more here. So this becomes a high pressure zone. This becomes a low pressure zone. So I am rubbing this one so in order to show the arrow, okay? So what happens when the air reaches the high pressure zone? The air here also, what happens is, okay, bifurcates into these directions as well as this direction, okay? Because last time only I have told you that, okay, from HP there is an outflow of air. From HP there is an outflow of air. In LP there is an inflow, okay, LP there is an inflow of air. So here in the HP you find there is an outflow of air in different direction in the north and south. So this air comes this side, this air goes that side, okay? So what happens? This area gets air, okay? So what happens is this area is also heated up, okay? So when it is heated up, the warm air rises. The warm air rises. And when it reaches the tropopause, this warm air cools down. The warm air cools down. So what happens? It, okay, goes in this direction as well as it goes in this direction. So what happens? This cold air sinks down like this way and basically creates a high pressure zone here and creates a low pressure zone here. Here also the same thing happens. When the air, cold air sinks down, what happens? It creates a high pressure zone here and the air bifurcates in different directions, that is north and south, and creates a low pressure zone here because the warm air basically expands here, okay, and it goes this side as well as this side. So here also what happens is this air comes this side, high pressure zone, it goes this side. Here also what happens, high pressure zone, it comes to the low pressure zone. So the air which is coming from the high pressure zone basically enters into the low pressure zone. So wind always moves from high pressure to low pressure. Wind always moves from high pressure to low pressure. Wind always moves from high pressure to low pressure. Now you can see here the third point. Wind always moves from high pressure to low pressure. So this is the way the wind moves, or the movement of the wind is basically felt in this area. Not only in this area, the same thing happens on this area also. I cannot draw it here. You can basically understand it by yourself. Okay. Now, one thing I want to tell you. Okay, there are cells made. Okay, there is a box made. There is a box made here. Okay, I am rubbing this one so that you can understand. Okay, clearly. Okay, there is a box made here. Now, this box are named differently. This is known as Hadley cell, because Hadley was the meteorologist who discovered this one. So this is known as Hadley cell. Okay, and this is also known as Hadley cell. Okay, this is known as Ferrel cell. Okay, Ferrel cell. So who is also the person who basically devised the Coriolis force. Okay, he is the person who made the Coriolis force. Okay, or understood the Coriolis force. Polar cell, okay, and this is also known as Ferrel cell, and this is also known as polar cell. Okay, now if you see, here, polar cell. Okay, now the first thing, you have to understand is, there are 7 pressure belts, and 7 pressure belts are defined into high pressure to low pressure, high pressure to low pressure, low pressure to high pressure, low pressure to high pressure. Now if you see here, they have different direction of the wind. Okay, now the wind actually moves in this direction. I am coming to that later on, when I am doing Coriolis force. First, so you can draw this one so that you can understand what it means. This is the direction of the wind. The arrows which I am showing here is the direction of the wind. This is the direction of the wind. And this is the direction of the wind here. And this is the direction of the wind here. Now I am coming to this, for your basic understanding only, I have basically drawn the direction of the wind. Now, one thing you have to understand is the rotation of the earth from west to east. So the earth rotates always from west to east. Deflects the wind or bends the wind. Actually in the northern hemisphere it bends towards the north, whereas in the southern hemisphere it bends towards the left. So there is a deflection of wind due to the rotation of the earth, and either causes them to pile up to form high pressure zones. So wind is one of the reasons, and as well as the rotation of the earth is one of the reasons which causes high pressure belts as well as low pressure belts. Low pressure zones has usually bad weather. So low pressure zones are always called LP are always called bad weather condition area. Whereas HP means happy area, where the weather is calm as well as fair. Therefore, it is called a happy zone. HP means happy zone. So low pressure zones usually have a bad weather conditions like stormy weathers, as it causes inflow of winds, because winds come from high pressure zones. So wind always moves from high pressure to low pressure. Remember that. On the other hand, calm and fair weather is found in the high pressure zone. So it is a happy zone where you have calm weather, as the cooler air sinks and gets compressed, means reduced in volume by pressure. So what happens is when the air basically comes, okay, to the high pressure zone, this area becomes, okay, an area of calm, okay, or the area of, okay, area of happy zone, okay, because the cool air sinks and get compressed by the pressure. So there is no, okay, stormy weathers, etc. in this area. Now pressure difference brings, okay, horizontal movement of air, okay, horizontal movement of air. So what is wind? Wind is the horizontal movement of air, and the vertical movement of air is known as currents. So the vertical movement of air is known as currents, okay. So vertical means this one. So the vertical movement of air is known as currents, whereas the horizontal movement of air is known as, okay, winds, okay. Transfer of heat is possible due to the wind, which makes earth livable or fit to live, okay. Now we are looking at, okay, circulation of the wind, and that time only I have told you wind always moves from high pressure to low pressure, okay, from a region of high pressure to a region of low pressure, and this movement of air is known as wind gradient, and this movement of air is known as wind gradient. So I am rubbing this, okay, little bit, okay, so that I can write something, okay. So I am rubbing this one, I am rubbing this one also. So that I can fit here, okay. So I'm putting a bar here so that you can understand, okay. Now wind always moves from a region of high pressure to low pressure, and this movement of air is known as pressure gradient. This movement of air is known as pressure gradient, G-R-A-D-I-E-N-T. Gradient means graded or change, okay, or what we call wind gradient. It is also known as wind gradient. It is also known as wind gradient, okay. Now pressure gradient force. So whenever we are talking about the wind or circulation of the wind, okay, so if you want to understand the movement of wind, we talk about the process of circulation. Movement of air is not a simple phenomenon, okay. It's basically complex phenomenon, okay. So pressure gradient force, okay, pressure gradient force. Whenever I am talking about the pressure gradient force, I am talking about the wind velocity, wind speed. I am talking about the wind speed or wind velocity, okay. Depends on the difference between high pressure as well as low pressure. So the areas which have high pressure, okay, and the areas which have low pressure, what kind of wind is that, okay. If there is little impulse, okay, so I am writing on the board, if there is little impulse, okay, little impulse, I-M-P-U-L-S-E, impulse means force or strength, okay, provided there will be little disturbance. Now look at this line, read this line carefully. If there is little impulse provided, there will be little disturbance, okay. When pressure is less, the speed of the wind is less when the pressure is less. When the pressure is less, the wind speed is also less as well as less disturbance. But when the pressure is more, what will happen? The speed of the wind will also be more and more disturbance. So I am writing the another one, okay. If there is more impulse, more impulse means if there is more force, what will happen? There will be more disturbance because the pressure is more, okay. More impulse provided, there will be little disturbance, but here it will be more disturbance. So there will be more disturbance here. So same thing, okay. So when the pressure is more, the wind speed is more as well as the disturbance is more, okay. So I am writing another thing, okay. Hope you have understood this one. I am rubbing the blackboard and I am writing another thing, okay. Slow moving air. Slow moving air means, okay, less wind speed means less disturbance. So there is less deflection. There is less deflection. You can see here, slow moving air has less deflection, whereas fast moving air has higher deflection. Now, what is the meaning of deflection? Deflection means it can bend, it can turn, okay, as well as, okay, it can divert, or, okay, there is a deviation found because of the pressure in the wind. Okay, wind is always basically, okay, basically caused by the pressure belts. So if the movement of the air is slow, then there is less deflection found. Where there is fast moving air, there is more deflection found. Similarly, polar regions have higher deflection. Whereas compared to the equatorial low. So high pressure belts have fast moving air, whereas, okay, low pressure belts have slow moving air. Okay, are you understanding? Example, you can look at your book, okay, that is a textbook, okay, page number 37, topic wind, okay, third paragraph, where you have, okay, go and fly a kite. But before flying, make sure of the impulse of the wind. Make sure of the force of the wind. It is a slow wind or it is a fast wind, okay. Kite flies in the direction of the wind or of the breeze, okay. Breeze is a gentle and light wind, okay. And light wind is needed for flying your kite. Otherwise, it will not go up in the sky. So what you have to see when you are flying the kite, okay, you have to see the slow moving air. You have to, okay, basically feel there is a slow moving air or a fast moving air. And you have to know the impulse of the wind also, okay, when you are flying the kite. Now, to understand this, we have to primarily understand what is Coriolis force. Okay, in order to understand the slow moving air and the fast moving air in different, okay, pressure belts, okay, we have to understand the Coriolis force. The Coriolis force is that force which defines the movement of winds in different, okay, latitudes. So what is Coriolis force? C-O-R-I-O-L-I-S. Coriolis force, okay? Coriolis force. Now, Coriolis force is a mass, okay, is defined as a mass, okay, of a moving body. Mass of a moving body in a rotating system. So, what is the definition of Coriolis force? Mass of a moving body in a rotating system. Let us understand this by an illustration on the blackboard, okay, which I am going to draw, okay, and I am going to draw a large rotating machine. A large rotating machine, okay. It's a replica of the earth, okay. It's a replica of the earth, okay. Large rotating machine with seats. I am going to make seats here. I am going to make seats here, okay, where the people can sit down, okay, made of dummy horses for children on amusement parks. This is known as merry-go-round. Have you heard of merry-go-round? Okay, this is a large rotating system, okay. Now, I have made seats here, okay. I have made seats here. So, the earth always rotates from west to east. So, it rotates in this direction. So, likewise, this merry-go-round also rotates in this direction. When you rotate this merry-go-round, what will happen? That we have to understand. Now, I'll make a small ball at the middle. This is a ball, okay. The ball is the mass of a body, of a moving body. Mass of a moving body, okay, in a rotating system. In a rotating system. The rotating system is the merry-go-round, okay. The rotating system is the merry-go-round. So, when the merry-go-round is rotating, if I throw the ball, directly to the, okay, number 1. Directly to the number 1. So there are 8 seats I have basically, okay, numbered, okay. If I throw this ball directly to number 1, when the merry-go-round is rotating, do you think the ball will directly land to number 1 when it is rotating? What would happen? The force would act perpendicular to the direction of the motion. To the direction of the motion is from west to east, and axis of rotation. This is the axis of rotation. So what will happen? Okay, it will act directly perpendicular. This is the axis of rotation and it will go this side. So what happens? The ball will get deflected and goes this side. What happens here? This, okay, movement or wind moment is basically applies Coriolis force. The ball, rather than going straight to number 1, takes a curvature path, okay, or gets deflected. That time I was talking about deflection, okay, gets deflected to number 2. Rather than going straight to number 1, it gets deflected to the right side. This is known as Coriolis force. The actual part of wind movement, okay, here is Coriolis force, because the Coriolis force is acting when the rotating system is basically moving, and when you throw a ball to number 1, it goes to the right side. Okay, so what happens is, due to Coriolis force, objects to the right, okay, due to Coriolis force, what happens is, okay, objects deflect to the right in the northern hemisphere. So this is the northern hemisphere and this is the southern hemisphere. This is the southern hemisphere. So if you are throwing the ball to number 1, in the northern hemisphere, it gets deflected to the right side due to Coriolis force. But if you are throwing the ball, okay, from here to the number 5, it gets deflected to the left side due to Coriolis force in the southern hemisphere. Okay, so I'm going to draw another diagram, okay, to make you understand this one, okay. So I'm going to draw another diagram. There is another diagram I'm drawing, okay. Now I'm dividing this circle into 2 equal halves, okay. This is the northern hemisphere, this is the southern hemisphere, okay. Now this is equator. Okay, this is equator, and when we move towards the poles, this is the poles, so where you have the northern hemisphere, okay, and the southern hemisphere, okay, where you have the poles. Now that time I told you, due to Coriolis force, okay, the objects that is found on the right side always gets deflected to the right, okay, in the northern hemisphere. So when you are throwing a ball in the northern hemisphere, what happens? It gets deflected to the right. So here also, when you throw a ball like this way, it gets deflected to the right. Okay, so I am making an arrow like this way, hope you can understand. So when you throw a ball like this way, it gets deflected in the southern hemisphere, so it always gets deflected in the left side. But here also, when you throw an object from equator towards the poles, what will happen? The object gets deflected to the left. So here in the northern hemisphere, it deflects to the right. In the southern hemisphere, it deflects to the left. This is known as Coriolis force, and the wind movement is like that. And the wind movement you find is like that in the northern hemisphere, and in the southern hemisphere you find it gets deflected to the left. Now if you look here, you can see the arrows here. Now you can understand why it is going this side. Why it is going this side in the northern hemisphere? Why is it going this side? Because on the right side, in the because in the northern hemisphere it always deflects to the right. In the southern hemisphere it always deflects to the left. Okay, are you understanding? Now I am going to rub these arrows later on, just now. Okay, this is called the Farrell's law. This is called the Farrell's law. This is called the Farrell's law. In the northern hemisphere, the winds are deflected to the right. So a north wind now blows from northeast and is called the northeast trade winds. In the southern hemisphere, as the wind deflects to the left, A wind blows from southeast and it is called the southeast trade winds. Now I'm going to draw where is the southeast trade winds and northeast trade winds. Okay, so I'm going to rub these arrows for your basic understanding. So I'm rubbing these arrows which shows the wind direction. Hope you have understood why these arrows are in different directions. Because of the Coriolis force. Because of the Coriolis force. Now, okay, what do you find here? You find here polar easterlies. You find here polar easterlies wind, okay? Polar easterlies. Here you find, okay, southwesterlies, okay? You find southwesterlies. Here you find northeast trade winds. Okay, here you find southeast trade winds. Here you find northwesterlies. If you look at the arrow, you will understand why it is called north, why it is called south. If you look at the direction of the arrow, okay, it is going towards the north. Okay, I'm rubbing this arrow right now, okay, and this is known as polar easterlies, E-A-S-T-E-R-L-I-E-S, easterlies. So you can see there are different winds found in different zones. So we have covered the Coriolis force here as well as, okay, pressure belts, okay. Now, both wind speed as well as wind direction are measured by wind vane, okay, measured by wind vane and anemometer. Wind vane records wind direction, whereas anemometer measures wind speed. We will read about this in detail in the next chapter. Now today we are doing another important point of the elements of weather, that is known as humidity. Okay? I'm rubbing the blackboard. Okay. Now we are doing humidity, okay? So I am writing it here so that, okay, humidity. Now what is humidity? Humidity is the amount of water or water vapor present in the air. How much water is present in the air, okay? Or in the atmosphere is known as humidity, okay? So amount of amount of water present in air is known as humidity. Now, how does our atmosphere becomes humid? Due to evaporation, moisture in the air or water in the air develops. Due to evaporation of what? Water bodies like seas, rivers and lakes. The rate of evaporation is rapid as well as high because of number one point is temperature. The second point that you have to understand here is wind speed. That time only we have studied about wind speed. Wind speed is caused by Coriolis force. Another one is, third one is when the sky is clear. So rate of evaporation is high or rapid due to these factors. When the sky is clear, when there is no cloud in the sky, so there is more warmth on the earth. So there is more temperature on the earth which causes evaporation rate or high evaporation rate. Humidity varies from time to time as well as from place to place because the humidity of air is determined by this factor called temperature. Different areas have different temperature due to the latitudinal position of the earth. Okay, warm air. So here also we come to warm air. Okay, warm air holds more moisture than cold air. Due to what? Due to evaporation, due to temperature. So humidity is higher in lower latitudes. Now, which are the lower latitudes? We are talking about equatorial low or equator, where there is direct rays of the sun, where the air is warmer than in the higher latitudes. So in the equator you find direct rays of the sun. Okay, when you have direct rays of the sun, okay, it hits both land as well as water as well as the air around it in the lower latitudes. But in the higher latitudes like the poles, where you have slanting rays of the sun, you have less temperature there, therefore you don't have too much humidity there. Okay, humidity is also higher in coastal areas than in the interior or in the inland or in the mainland. Okay, where you have, okay, what we call, okay, land. Humidity is higher near the coast, where the land meets the water. Okay, you have more humidity there. Due to what? Due to convection. Due to convection. C-O-N-V-E-C-T-I-O-N. Convection. We are talking about three types of heating. Okay, insulation. Okay, convection, as well as, okay, I forgot the one. Okay, you can refer to page number, okay, 34 for that. Okay, and see convection there. Okay. So, moreover, higher humidity is experienced during summer season as warm air expands and rises up and can hold more moisture. So, warm air holds more moisture than, okay, cold air. But there is a definite limit to how much vapor or water can our atmosphere hold or can our air hold. When the air is holding the maximum amount the air can hold, we say that the air is saturated. Now I am going to draw, okay, pockets here, okay, air pockets here on the blackboard, okay, to make you understand what is called saturation, what is called unsaturated. Okay, saturated and unsaturated air. Okay, so I am drawing air pockets here. Okay, I am drawing boxes here, same, okay, size boxes I am drawing here. Okay, to make you understand humidity. Now, for example, okay, in this air pockets, there are 4 air pockets, 1, 2, 3, 4. These are known as air pockets, P-O-C-K-E-T-S, pockets. Okay, the maximum quantity this air pockets can hold is basically 100%. 100%. So each boxes can hold air pockets up to 100%. Okay, capacity of this air pockets I am talking about. Okay, when the air is holding the maximum amount the air can hold, we say that the air is saturated. That time I was reading this one. Let's take for example, there is air in this box. Do you find any water vapor in this box? I don't think so. So here what will happen, the relative humidity. The relative humidity is the amount of air or amount of water present in the air is known as relative humidity. So there is no only air here in this air pocket. So relative humidity is 0. Okay, as well as the AH means absolute humidity is 0. Okay, but here I will draw a line here. Okay, and basically mark it here. Okay, that the water present in this air pocket is basically 50%. 50%. So here you have water, here you have air. So 50% of RH is here. Okay. Here I am drawing another air pocket. Okay, where I am writing here. Okay, water is here present and here is air. Now you can see the difference here. Okay, where you have RH level is basically 75%. Okay, RH level is basically 75%. And here I am going to draw the whole, okay, air pocket with water. So water, 100%, okay, water in 100% air pocket. So you can look at this diagram, okay. Now when the air is holding the maximum amount is 100, okay. When the air is holding the maximum amount of water, okay, in the air pocket or in the atmosphere. This air pocket is the atmosphere. So when the air is holding the maximum amount of water, okay, then the air is called saturated. That the air is called saturated. The hotter a place, the more water vapor it can hold. So when the place is hot, the water vapor content is also more. When the air holds less than its maximum quantity or maximum capacity, so if the air is holding only 50%, then it is called unsaturated. When it is holding the maximum amount, okay, then it is called saturation. Okay. Unsaturated air can become saturated if the temperature decreases, while saturated air can become unsaturated if the temperature rises. So in order to understand this process, we have to look at this illustration on the blackboard. Okay. So I am going to draw another diagram on the blackboard. Okay. Now these air pockets are of different sizes, okay. So I'm going to draw, okay, 5 air pockets. I'm going to draw 5 air pockets. These are also air pockets which I'm going to draw. Okay, I'm drawing 5 air pockets of different heights. Of different heights. Of different heights. Now I am drawing 5 air pockets here. There are 5 air pockets in the diagram, okay, on the blackboard. Number 2, number 3, number 4, and number 5. So these are basically air pockets. And in the middle pocket, so the number 3 pocket, okay, I am going to fill it with, okay, air, okay, and water. So and in the middle pocket you will find that the pocket is half full. Half full means 50%. 50% of RH. Relative humidity is 50%. Relative humidity is 50%, okay. The way we can measure the amount of water in the air, okay, is known as relative humidity. Relative humidity means the amount of, okay, water present in air is known as relative humidity. RH means relative humidity. The word relative means compared to. So relative humidity means how much water is in the air. So how much water is in the air? This is the air pocket. So this air pocket is similar to atmosphere which surrounds our earth. So how much water is in the air compared to the temperature of air? So temperature also we have to see, okay, as well as the volume of air pockets. How much, okay, space the, okay, air pockets have. That is known as volume, or so space of air pockets or mass of air pockets. It is written always in percentage. Therefore, I have written in percentage. Okay. Now what it means here in the middle is, okay, the RH of this pocket is 50% as the air pocket's volume is 100%. But if you look at this air pockets, the maximum capacity of this air pocket is 100%. But what happens when we warm this air up? But what happens when we warm this air? Okay? As the air is heated, the molecules moves faster and spreads further, creating more volume or volume increases. This basically means we are creating more space. So when we raise the temperature of this air, when we raise the temperature of this air, what will happen? If I put the same quantity of water in here, what will happen? The water level decreases. The water level decreases. Same quantity of water, if I put it here, what will happen? So it creates more volume, more space. The water is not taking too much space in the second volume, as well as in the first. When we increase the temperature of these air pockets. When the temperature rises, humidity goes down. When we raise the temperature, what will happen? Humidity goes down. Humidity goes down. So we can again read that line which says, saturated air can become unsaturated if the temperature rises. When the temperature rises, the humidity decreases. When the temperature rises, humidity decreases. Remember that, okay? Now, unless there is a source of water vapor, to put into, then only humidity rises. So what happens if we again cool this water, water vapor from here? If we cool down, what will happen? The volume decreases as well as the space is going to decrease. The amount of water vapor is going to increase from pocket 1, to pocket 2, then pocket 3, then pocket 4. What will happen? It will rise. Then in the pocket 5 you will find it has filled all the spaces. It has filled all the spaces and there is no space here. As we cool down this air pocket from number 1 to number 2, number 2 to number 3, number 3 to number 4, and number 4 to number 5. If we keep on cooling down this air pocket, what will happen? The volume increases as well as the space increases, as well as the vapor content also increases. The space is gonna decrease here. At this point, the RH in the fifth pocket, if you look at the fifth pocket, you find, there is no space. All the space is gone. The RH is 100%. The RH is 100%. How much water vapor is in this air pocket number 5? 100%. So the RH is 100%. This is the point which is known as saturation. This is the point which is known as saturation. This is the point which is known as saturation. That temperature is called the dew point. That temperature is called the dew point. The temperature, the freezing point is called the dew point. This is the point when it reaches saturation point, this is called the dew point. This is called the dew point. When we continue to cool it down even further, what is going to happen? Condensation takes place. Condensation means the process of changing from a gaseous to a liquid or to a solid. So condensation takes place and clouds are formed, and eventually precipitation takes place after the dew point. On further cooling from the dew point, what will happen? For further cooling from the saturation point, what will happen? Condensation takes place. Now, what is absolute humidity? Absolute humidity is the actual amount of water vapor present in a unit volume of air. How much volume is there? 100%? 100% is the maximum capacity of this air pocket. So how much water is there in the air? So only 50% is there. This is known as absolute humidity. We are not going to look at temperature in absolute humidity. Regardless of temperature, but volume, but we are looking at the space, okay, must be considered. It is expressed in grams of moisture. It is expressed in grams of moisture per cubic meter of air, okay. So absolute humidity. So I'm rubbing the black, okay, I'm writing it here, okay. Absolute humidity is basically measured in grams per meter cube, okay, or kg per meter cube, okay.